Best of Our Knowledge explores topics on learning, education, and research. Coming up, can you imagine early humans over 2 million years ago using tools? Maybe not, but guess what? They did. Technology has been a major part in our evolution as humans, and stone tools were some of the beginnings of what we recognize as modern technology. We will explore a discovery of stone tools found in Kenya's Turkana Basin to learn more about early technology and humans. You're listening to the Best of Our Knowledge. I'm Madeline Reynolds. Between 2 and 3 million years ago, during the Pliocene epoch, our ancestors were forging their way in a climate that was ever-changing and dangerous. As our species evolved into the advanced and intelligent modern human of today, the thought of early humans using tools millions of years ago may seem impossible, but it's not. In modern-day Kenya Turkana Basin, researchers have discovered stone tools dating back to that time of ancient humans. The Earth was going through major climate change, where huge lakes were becoming tiny rivers, leading to drought, raging fire, and even shifting ecosystems. Our ancestors were trying to survive and adapt to this world. These stone tools that were found at a Kenyan site reveal that what was happening to them was spurring a fertile period of invention. So, with about 300,000 years of intense climate swings, early humans were able to survive as well as maintain stone tool traditions. These stone tools were made to help them adapt as well as live. I spoke with David Braun, a professor of anthropology at George Washington University and a research affiliate at the Max Planck Institute for Evolution Anthropology, to learn more.
Yeah, sure. The most of, well, no, all of the material that we know about from this time frame is in the East African Rift Valley, so a place in Eastern Africa between Ethiopia and Tanzania, where the Earth is literally opening up, where we can actually see these deposits, and it's at a place that was a pretty dynamic landscape, and not very much like it is today, in the sense that we know there were, large elephants and giraffes and lots of things that don't exist there today. But we also know that it was a time frame when, especially the 2.75 to 2.44, where the sort of regional climate showed some dramatic changes. So it did go from, the area was a very large lake at the beginning of this time frame, and then it dropped to being sort of small rivers, and an extremely dry habitat, right? So it shifted quite dramatically during the time frame when we know these early tools were found. So, and that was one of the sort of components of this, is that even though we see sort of major changes in environment, early humans seem to be able to use stone tools and technology in general to adapt to those environmental shifts.
So, could you also, before we get into the nitty-gritty of this research, could you talk a little bit about the humans that were alive back then as a species? What were they like? Like, what was going on with them?
Yeah. So, the interesting thing about this particular time frame is that we have a fantastic fossil record of our ancestors from around about 3 point, let's say 5, 7, up until pretty much 2.5 million years ago. The time period between 3 and 2 million years ago, for whatever reason, is extremely poorly known. And we know way more about hominin or early humans that are 3.4 million than we do about the ones that are, 2.7. And it's a particularly important time frame because before that, we are effectively looking at early humans that are quite short in stature, right? They're relatively small brained. They have a dental apparatus that is kind of halfway between a chimpanzee and a human. But I think our early impressions of these is kind of sort of like a chimpanzee that spends a lot of time on the ground, right? And that walks upright. And then by the time you get to 2 million years ago, you've got something that is completely different, right? That is, 6 feet tall, has a very long body form, a very large brain, a dramatically adapted teeth. And so somewhere between those two endpoints is kind of we're smack in the middle of where that is. And in fact, there's not a great fossil record. So I would, if I had to guess who made these early stone tools, I'd probably guess that probably someone or some kind of species that is ancestral to us, and probably quite short, and probably a relatively small brain. But exactly who it is actually really hard to say.
So, how did you conduct your study into this all? It seems pretty long from what I've read, so it's
Yeah,
cool.
yeah. So we were interested in finding, so before we published this paper, we had known for about 40 years that stone tools start to appear at around about 2.5, 2.6 million years ago. Um, but for years, people have been looking for things older than that, and it just appeared as if they weren't there, almost as if there was a kind of watershed moment at 2.6, and then after that, early humans are using these stone tools. Um, and so we were looking for deposits that are much older. We found these tools quite some time ago, almost 15 years ago, and the difficulty was that this is in a place where there are a lot of volcanic ashes. So we use volcanic ashes to be able to estimate the age of sites, right? Many of them up above and many of them below, but in between, not so many. So it actually took us, many, many years of going, taking samples, bringing them back to the lab, analyzing them, and then trying to get a sense of the age of these different deposits. And that's why we ended up, it was not our initial intention to look for a long period of history where there are stone tools. We actually thought these sites were all the same age. But then as we were doing the dating, we realized actually, no, they're not the same age. They're actually over a series of time, an extended period of time. And so that was a kind of late understanding. We were actually doing the analysis under the assumption that they were all the same, and then once we actually started getting the data back for the dating, we realized, okay, no, these other sites over here are actually well hundreds of thousands of years younger. So, which was also surprising because, and this is one of the other kind of surprises of this study, is that it looks like they really know what they're doing even at 2.75 million years ago, right? That this is not the first time they've done this. And that is one of the sort of conclusions of the study, is that we're sure, or I'm reasonably sure, based on this, that there must be sites that are much older than this. Because this doesn't look like when early human ancestors first invented this. They're way too good at it already. So.
You're listening to the best of our knowledge. I'm Madeline Reynolds. If you're just joining us, we're learning all about stone tools and early humans with David Braun, a professor of anthropology at George Washington University and a research affiliate at the Max Planck Institute for Evolution Anthropology, to learn more. So, Namoro Tukunan in Kenya is the site where you found evidence of tool usage from millions of years ago by early humans. Could you talk about what your time was like being there on that site, digging up these tools, seeing the land? Was it fun? I mean, what was it like?
Yeah, I mean, this place is one of the more remote places on the planet, right? It takes us 3 days just to get within to get to where the camp is that we stay. And then it takes another 2.5 hours on a good day to get to where the actual fossil site is, or where the archaeological site is. And it is there's a component of it that because there's lots of very small little pebbles and it's very resistant to erosion. So the slopes on the hills are very steep and they're covered in little tiny pebbles. So most of the students that we bring there have spent at least part of their time rolling down the hill of these, because it's very hard to keep your footing on some of these. So, and it is an extremely warm location, being in a semi-desert near the equator. But it is quite dramatic because of the fact that there's these very steep and very tall hills, so that you can actually see deposits that are, over hundreds of thousands of years, and you can also see changes in the geography, right? It basically goes from this lake, so you have these dark lake clays, lots of fish fossils at the top, and then it becomes this river system, and you can kind of see places where the river cut out and then deposited. So it's quite a dramatic landscape, but not a very easy one to spend, 6 weeks in the summer. So.
So, what were the type of tools that you found that these early
Yeah.
humans were making? I would love for you to describe them, like what materials they used and things of that nature.
Yeah, so interestingly, the the to you think of these things as sort of knives that early humans, and the reason why it's important to think of them as knives is because really the tools provide cutting edges, which is something that when you are an early human and the teeth that you have are kind of reducing in size, the only way that you can cut something is with a tool, right? We don't have the large canines that other primates have. We don't have claws. We don't have any other thing. If we want to get into something that requires a sharp edge, we have to make it kind of extra somatically outside of our body. And so these early humans were able to find rocks. And the really interesting thing is that the rocks that they found that are really good for making sharp edges, and in fact, so good at doing that even modern day people who use stone tools will go and find this same rocks. They found very specifically those ones that on the outside they look almost like chalk, but if you break them open, you can see that they're basically very sharp, and they're very sturdy edges on the inside. So they were able to actually, go to the edge of a river and pick out those specific rocks that were really good for making these, sharp edge knives, and then consistently make them over and over again. And even though, it's basically just breaking rocks, right? Hitting one rock against another, it's a relatively simple technology. But when you think about the fact that you need to understand not only what do rocks look like on the outside, not the inside, but also have to understand the kind of mechanics of how do things break. It's something that's actually very difficult for many other species to emulate. And so they had figured out, these are the rocks to get, and they figured out how to break them, and did that consistently over and over and over again. And so that's why we think, this isn't it's not their first rodeo, right? This they've done this before, because they really know which rocks to get, and they're making lots of these sharp edge tools as they're doing it.
So you kind of talked about the volcanic ash and that being used as a way to date the tools. I'm wondering if there was other ways that, like other data or materials or things, fossils, maybe
Mhm.
that you collected to also maybe date the tools besides volcanic ash, like you talked about before.
Yeah, so the main thing that we use, and the reason why it took so long, the main thing that we used is what's called paleomagnetics. So the Earth has a magnetic field, and that magnetic field, right? So we hold the compass, magnetic points north now. But if you were to hold that same compass, and it was 800,000 years ago, that compass would point south, right? And that's because the Earth's magnetic field flips every once in a while. It goes back and forth. And so we can actually just take samples of just dirt and then, a lot of detailed analysis to try to figure out, was the Earth's magnetic field the same way that it is now, or the way it was, or was it reversed? And by doing that, we know very specifically those time blocks when the Earth's magnetic field flipped back and forth. And unfortunately, all you get is reversed or normal. So you just get like a sort of binary, and then you kind of have to piece together this barcode of reversed and normal events to try to figure out where they were in the past. And that's what the main data that we used to actually identify exactly how old the deposits were. We also were able to see fossils. There are some fossils in there. It's not a tremendously fossiliferous area as compared to other parts of northern Kenya, but we were able to find some fossils that show that these areas must have, these are extinct species. So the area must be older than a certain time frame. And then the other thing that we were able to show is this kind of dramatic change in climate, which is actually well documented all over throughout Eastern Africa, so that we could tell that this was kind of corresponded to different changes that happened elsewhere in Eastern Africa. So.
You're listening to the best of our knowledge. I'm Madeline Reynolds. I've been speaking with David Braun, a professor of anthropology at George Washington University and a research affiliate at the Max Planck Institute for Evolution Anthropology, to learn more about stone tools and early humans.
So I want to talk about the tools a little bit more.
Okay.
And you just kind of talked about how they had it, extensive during that time, change in land and climate and things of that nature. In regards to tools, the tools that they made, what changed for early humans in terms of, their habits or even behaviors or life when they made these tools? And was that, brought upon by this huge climate change that they experienced at that time?
So this gets into a bit of a speculation, but I'm happy to go there.
Okay.
Um, we don't, we know very little, or we actually, it's very hard for us to know what their behaviors were before they make tools, right? Because all we have is their body fossils, right? But we can look at the kinds of things that our closest living ancestors do, right? And so, for example, modern chimpanzees and other animals, they use tools, but they largely do it to gain access to things like nuts and break open other hard cased shelled items. But the one things that they don't necessarily do, and most of the time they don't do it because they don't need to, is cut things, right? And the one thing that is very distinct for early humans is that we recognize large dead things as food, right? Chimpanzees don't, right? If they see a large carcass or something like that, that's not food, right? They will go and kill animals, like smaller animals, things that are smaller than them, but they don't recognize carcasses as food. And early humans definitely did that. And we know that because we have marks on the bones that are the evidence of the butchery practices, right? So we can see that they use these tools to cut into things. And that we know from even these earliest sites. We have marks on the bones that show that they're doing that. And so that is one thing that, it's not so much speculation where we know that that has changed. They have the ability to use tools to gain access to large carcasses, and they appear to be doing that. Now, what would that have changed for early humans? For one thing, it would have given them access to a kinds of resources, animal tissues, that maybe previously they weren't able to get access to. But it also means it puts them into competition with large carnivores, which is not, anybody who spent any time in East Africa knows you try to spend as little time around large carnivores as possible. And it also exposes you to a bunch of pathogens, right? Because dead things have pathogens in them, right? Yes, it would have given early humans the ability to access new resources and really dense food items, but it also would have changed a lot about how they interact with it and the kinds of diseases they would have been exposed to and the kinds of animals they interact with. So potentially a really dramatic shift in their biology. And we think that change fueled the changes we see in our biology later on, increase in brain size and body size.
So, after speaking with you, it seems like that climate and the changing of the environment kind of maybe even forced these early humans to create stone tools, or to adapt is a better word, I think. And, these findings proved that early humans were able to comprehend to, make stone tools to cut and things of that nature. And like you've alluded, maybe because of the craftsmanship in these tools being found, they were using these earlier on. It wasn't just something they created on the whim. This was maybe something that was more developed. So what can we learn from all this and about these humans? And, you've already alluded that there possibly is older sites that have evidence or fossils of stone tools. So what can we just learn about all of this and everything that's encompassed in it?
I think probably one of the biggest takeaways here is that for a long time, we used to think of humans as sort of the tool using primate, right? And we've kind of done away with that. We know that other primates use tools. But what it seems to me is that given how well they're using it and how much they're using it to adapt to these different environments, that what we should really think of is our lineage as primates are tool using primates, right? That the lineage of apes and primates that we come from probably using a wide array of tools, and that tool use, we think of it as kind of a unique feature of our own particular lineage, but is probably actually a kind of feature of the variety of primates that are adapting to all these different things. So it's kind of our ancestry is to use technology to adapt to things. And it goes probably pretty far back in our ancestry. So that's, I think, to try to kind of shift to this idea, we often sort of think what makes humans special. And it's actually like what makes humans special is the fact that we belong to this group that's called primates. And these primates are very adaptive species.
Yeah, and we're still using technology today to adapt to things, right?
Yeah.
So, for you, what do you find the most fascinating about this research?
I mean, there is definitely a component of we spend a lot of time looking all throughout, very large areas finding nothing. We also dig holes that have nothing in them. So finding some of these things is actually quite satisfying when you finally do. But the other thing that I find, tremendously that I get a lot out of is being able to work with my colleagues at the National Museums of Kenya and with young scholars from Kenya, from Ethiopia, who just have a huge amount of excitement and interest and also stewardship of this heritage. And that is every time I spend every summer in the field with my Kenyan and Ethiopian and Tanzanian, Ugandan colleagues, and also young people from George Washington University. But having those people out there and seeing their enthusiasm and their excitement, that's what keeps me going and back all the time. So I think that's probably the sort of drive to keep on doing it. But also, seeing how much this has changed, even just the last 15 years, it makes, you realize that every time we go out there that we're probably going to find something we didn't expect. And that's what's exciting is, what is it? What's the next thing that we didn't expect to find that we're going to? So.
And then my final question to you is, what are you researching into, maybe regarding this topic or a new one? What's next for you on your plate?
So, like I said, we found these things 15 years ago, right?
Right.
We spent a lot of time honing in to make sure we knew exactly what these were. But since that time, we spent a lot of time, because like I said, we was like, wow, these things are actually 2.75. They're really good at this. And so we spent a lot of the last couple of years really kind of exploring not only the older deposits, but trying to start to think of, if they're that good at making stone tools at 2.75 million years ago, they must be really good at a variety of different tools, right? And so trying to find ways of what other kinds of tools might they be using. And I don't want to give it too much away, John, but I can tell you that they're doing a lot of different, very interesting things, probably much earlier than we. I mean, one of my good colleagues, John Shea, says if you want to be wrong, underestimate our ancestors, and I think that's what we would do. And so.
That was David Braun, a professor of anthropology at George Washington University and a research affiliate at the Max Planck Institute for Evolution Anthropology. His research was originally published in the journal Nature Communications. If you'd like to tell the best of our knowledge what you think, send us an email at knowledge@wamc.org. You can listen to the best of our knowledge anytime as a podcast, downloadable wherever you get your podcasts. If you want to catch up on past episodes or hear more WAMC National Productions programs on the news, academic study, books, women's issues, the media, and the environment, visit wamcpodcasts.org. This has been The Best of Our Knowledge, episode 1832. The Best of Our Knowledge is a national production of WAMC Northeast Public Radio. The latest on all National Productions programs is available via the Airwaves newsletter and our flagship station's website, WAMC.org. Until next time, I'm Madeline Reynolds.